How did microprocessors evolve from vacuum tubes to modern chips? Imagine a world where computers filled entire rooms and used giant glass tubes to process information. Now, picture tiny chips that fit in your hand and power your smartphones. How did we get from those huge, fragile tubes to the sleek microchips we use today? Let's take a quick journey through this fascinating evolution. Back in the late 1930s to the mid-1950s, early computers relied on vacuum tubes. These glass tubes had electrodes inside that controlled electron flow, allowing computers to switch signals on and off. But vacuum tubes were big, used lots of power, and often burned out. They generated a lot of heat and failed frequently, making early computers slow, bulky, and expensive. Only large organizations could afford them, and maintenance was a constant challenge. Then, in 1947, the invention of the transistor changed everything. Transistors are tiny semiconductor devices that can switch and amplify electrical signals. They are much smaller, use less power, and are more reliable than vacuum tubes. Transistors could be packed closer together on a chip, which meant computers could become smaller and faster. During the late 1950s and 1960s, companies like IBM and Digital Equipment Corporation started using transistors in their computers, making them more accessible and dependable. The next big step was the creation of integrated circuits in 1958. These chips combined many transistors and other components onto a single piece of silicon. This drastically cut down the size and cost of electronic devices. The manufacturing process, called planar technology, developed in 1959, allowed mass production of integrated circuits with increasing numbers of transistors on each chip. This was a game changer for electronics, enabling more complex and powerful devices. In 1971, Intel introduced the first microprocessor, the Intel 4004. It was a tiny chip with thousands of transistors that could perform calculations and execute instructions. This meant entire central processing units could be built on a single chip, making computers smaller, cheaper, and more efficient. This invention sparked a wave of innovation, leading to faster, more capable microprocessors. Over the years, microprocessors improved in many ways. The bit width increased from 4 bits to 8, 16, 32, and beyond. Processing speeds grew rapidly, and multitasking became possible. For example, the Intel 8086 introduced the x86 architecture, which is still used today in many computers. The development of smaller, more powerful chips followed Moore's law, which predicted that the number of transistors on a chip would double roughly every 2 years, while costs decreased. From the bulky vacuum tubes to today's tiny silicon chips, each step in this evolution solved key problems: size, heat, reliability, and cost. The transition from vacuum tubes to transistors, then to integrated circuits, and finally to microprocessors, has driven the growth of digital electronics and embedded systems. Now, microprocessors are everywhere, from computers and smartphones to cars and industrial machines, powering the modern world with their incredible speed and efficiency.